Good morning, friends. This is what we did and covered. We talked about on Wednesday and today, Thursday. So Tuesday the 12th or the 13th, because this is our block day recording on Newton's first and third laws. So the first thing is your do now. So depending on which day of the week you are, you're going to answer the do now. How or when does the motion of the objects below change? And do you know why? Let's take a look at it. First row, we've got a big old brick there. Two guys in the middle are pushing on the left and the right. Not seeing much movement, but when they both push from the same sides, they get the object moving. In the bottom row is a soccer ball sitting there. The first force that acts upon it is the foot kicking the ball. The second force, now the object is in motion, and it's staying up in the air until it meets one more force, and that's the net which stops it. Let's take a look at that some more as we talk about our learning targets. So we're going to investigate and describe Newton's first and third laws of motion. I can use the word inertia. I can give and identify examples of inertia. I can describe the first and third laws of motion. And I can complete an investigation of the first and third laws of motion. And we're going to describe force pairs, and that's pretty easy. It's the way the force is pushing on the object. So the first thing we're going to say is we're going to look at these two worksheets. The first worksheet we're going to look at has Friend Flintstone on the top. Now, if you come on over to your assignments folder, since you weren't there with us, you're going to want to click on the absent work for Newton's first law. And there you're going to find the sheet, and you can click it. If you can't, the back part is some things we addressed. There's a video you can watch in today's slides to fill in there. But the others you can probably Google or search in YouTube and see videos to answer those questions to the best of your abilities. So now I'm going to go back to our slides. So here we have Fred and Barney, and they're riding along. If you don't know who they are, they're the two guys here. They're the Flintstones. Fred is the guy with the dark hair. Barney is the guy with the yellow hair. So the car is moving at a constant speed, so the forces are acting upon the car are, that's right, they're the same because the car is moving. All right, forces acting on the other two, both cars are different. Because if you look, this is a smaller arrow, and there's a smaller car here, and there's a larger car and a larger arrow to give you a picture view. So the motion of the cars will actually be different because the forces are unbalanced. They're not the same. We talked about that last week. So let's talk about Newton's first law, and it kind of has two parts. With no outside forces, that ball, that motion, that object will never move. But there's also, with no outside forces, that this object here on the bottom that's moving is never going to stop moving. Unless, and let's talk about that. So Newton's first law of inertia, or first law, inertia, that is an object in motion, and you can just type that in, motion, motion, will stay in motion at the same speed and in the same direction unless a force, and probably an unbalanced force, changes the direction. Then objects at rest will stay at rest unless another force makes them stop. So the more mass we have, the more inertia, and the less mass we have, the less inertia. So the mini labs we're going to do in class today are listed here on this. We're going to do an NFL video, Go Puck Go, a flying teddy bear fiasco, and the bouncing penny cup. So we're going to take a look at these. I'd like you to write in full sentences because as we're getting ready for STAR, we need you to write in full sentences. Now, I can't play this video and have it recorded and watch in your setting, but this is a great video. You can click on this or click on the video in the daily slides and answer that first question. You could probably Google and YouTube hover pucks and find some activities to answer that question. We talked about how force is measured using the spring scales. Probably Google something on that. The flying teddy bear fiasco. Lots of stuff. This has to do with seatbelts and not seatbelts. So you can always find something on that. And lastly, we have a penny flick. That's right here. And you can also put it into YouTube as law of inertia. You probably find tons of stuff. So that's really what we were doing this first part. And then I had you turn and talk. So once you watch those videos, maybe fill out the back of the form to the best of your ability. Turn and talk and figure out, do you know what inertia is? And it's really kind of simple, that an object in motion stays in motion, or an object at rest stays at rest until an outside force acts upon it, causing it to start or stop. The second thing we did was Newton's law of third action. So I'm going to go back here to our tabs, and right here, here's the absent work form. You just click on that. And there we go, and it takes you here, so you can click on your, remember yours looks a little different than mine. Now Newton's law of action-reaction, or his third law, is that for every action there's an equal and opposite reaction. Yep, so look at the diving board here. When you jump, the diving board, you jump pushing down, the board pushes back up. Same on a swing, when you push, the person goes forward and then comes backwards. So the greater the mass an object has, the greater, you're right, the acceleration it has. The smaller the mass, the less the acceleration. Oh wait, we may learn that to be different. But let's keep going. So here's some Newton's laws, some pictures, teeter-totters, action, reaction, equal and opposite. Here's a rocket ship. We got to have enough action here to put in the engine to push the rest of the rocket. A swimmer, same thing. So the soccer ball accelerates to the left because it has less mass than that force that's acting on it. So equal mass, the greater the acceleration. We have to have the same, we have to have at least the same or better so that we can push that. So our second mini lab is another video, and we're going to look at that in a second, and bumper cars and roll with it in Newton's toys. Same ideas. Here we go. So this is a video. You can click on this in the daily slides to watch this one. So yeah, you have 2 tabs open. Answer that first question. Probably could Google bumper hover cars, hover pucks, and get that to roll with it. This is your own with a ruler and marbles. It's called a Newton's cradle. So you could probably watch a video on a Newton's cradle and get the same concept. And then our Newton's toys, we have these that are, you guys can call them the clackers. And then we have the little animals on springs. When you push them down, you wait, and then they spring. So those are some things for you to use. All right, everybody, I will see you tomorrow in class. Have a great one.